This is the video report from our glider, which I've named Coinhead. Let's get started. Alright, first off, we need to go over the glider design process and basically what this presentation is going to be covering. We're going to go over the requirements first, explaining the requirements for the design that helped us design around the constraints and objectives, which helped us kind of put together what we needed to basically have for our glider. And then I'll go over the alternatives that I've come up with. Alternative designs could include like different wing shapes that I could have used, or tail trims, or even where I put the center of gravity. And then we'll go over the initial design. We'll go over the initial design review and look at the initial concept drawing that I drew up and look at the requirements that I've tried to create for those. And then finally, we'll look at the final design and all the changes that have been made. All right, requirements. Requirements are to act as both constraints and a guideline on how to construct a project. So for our project, all of these requirements as shown were either derived directly from the document, source document, such as being able to fit inside a 16 by 16 inch box. That was directly from the assignment instructions. And then other requirements, such as being able to make stable flight, are derived from other requirements from the source document. Because if we look at number 4, shall make stable flight, derived from 2, shall have a positive 20-foot displacement in one direction. In order to have a 20-foot displacement, that implies that we need to have some sort of stable flight. And for that reason, I decided to include that requirement. And then number 6 is an environmental requirement. Because we are throwing these gliders outside, these gliders must be able to withstand the environmental factors. All right, here is the analysis of alternatives that I've come up with. So on the top left, we have a decision matrix for the wing type, ranked, and then several wing types listed below, rated from 1 to 5 in these 3 categories: ease to manufacture, lift generated, and stability. As you can see, when we sum up the total values generated, the rectangular airfoil had a higher value than the others that were considered. Therefore, the rectangular airfoil is what I chose for this glider project. And then below that, there is airfoil shape, such as if I wanted to camber it, make it symmetrical, flat bottom, or not have a camber. Because balsa wood is so light and brittle, it would be extremely difficult to properly camber the wings, even though the advantages that it generated would probably have made the glider a lot more aerodynamic. So I decided to go with no camber, as you can see by the sum of all of the values. There was also another decision for where the center of gravity could be, but after some research, it was ultimately decided that it should be a third of the chord length of the front. Next up, we have a initial design review. This is the first iteration of the design and was submitted for glider like checkup 1, I believe. This design was just an initial thought at how I should create the glider in order to meet all of the requirements as stated previously. Here we have a picture of the initial design. All right, the next stage of the design process is when we have looked over the initial design and tried to manufacture it, and then taken into account all of the issues that might have occurred, and then trying to fix those. So for this step, I actually made the glider, and then I realized that some of my initial design processes would not be good, basically. So the most major changes that I made was that I scaled the glider up to make it larger, and then I added more weight to the nose in order to shift the center of gravity forward to the half chord length, because previously the center of gravity was somewhere closer to the like back quarter of the chord, which was not ideal. Here we have the flight. Here we have the flight and the analysis.
Get set. Go. I don't know if it's.
Oh my gosh.
All right.
My glider flew a total of 65 feet in roughly 4 seconds for an average velocity of 16.25 feet per second. The glider weighs approximately 2.3 pounds and has a wingspan area of 31 inches squared. After running all the calculations, the coefficient of lift, induced drag, and final drag are listed.
Get set.
The conclusion of this project is that this was a pretty fun project overall, but it also allowed for us to incorporate all of the facts that we've learned throughout this class and put them together into an interactive and hands-on experience. The impact of the changes that I made, was that the flight stability was increased, the distance flown was increased. The deficiencies that I found were that the tail trim was incorrect, which led to decreased stability. Further improvements that I could make would be to readjust the tail trim and add more weight, but overall, this glider far met my expectations. Here is a list of all the sources used.